Okay, so if I were you, I would pause right here. These are your definitions that you need to copy down in the terms to know section of your notes, which is right after that pyramid thing and right after classifying numbers. But anyways, pause here, get your definitions going, and then click play when you're ready. All right, so now we're gonna look at this little cheat sheet. It's not in your notes, but hang with me. So we're looking at perfect squares. What the heck is a perfect square? Well, all the sides have to be equal. In order to find the area of a perfect square, we always multiply side times side, which we could also say is s squared. And remember that 2, that exponent of 2 means that we're multiplying a number by itself twice. So if we jump down here to where it says 1, it says that the side length of the square is 1. So what is side squared? Well, that's going to be 1 squared. And then the area would be 1 times 1, so it's 1. 2 squared would be 2 times 2, and that's 4. 3 squared, so on and so forth. We got 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and then we just flip-flop those last two numbers to get to 14 squared, which is 196, and then 15 is 225. So all of these big numbers here are perfect squares. They are known as perfect squares because they are the area of a square. And then we kind of talked about square root. Well, square root is this little radical symbol. What if I asked you for the square root of 4? Well, if I'm asking you for the square root, I'm asking you what was that side length. Well, if I look here at 4, and I want to know what the side length is, the number at the very top. Well, what is the square root of 4? It's 2. What is the square root of 121? That's going to be 11. Vice versa, 11 squared is the side times the side, and that gives me the perfect square area, which is 121. I hope that makes sense. All right, so you are responsible for memorizing the perfect squares of 1 through 15. So that's technically 1 through 225, and there's 15 of them. You are also supposed to memorize perfect cubes. Well, likewise, with the area, we did side times side. Well, to find the volume of a cube, it's always side times side times side. Or s cubed, which is why we call the third power cubed. So 1 to the third power, 1 times 1 times 1 is 1. 2 to the third power, 2 times 2 is 4, times 2 is 8. 3 to the third power, 3 times 3 times 3 times 3 is going to be 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power, 216. 7 to the third power is 343. It's kind of weird. I don't have these memorized, honestly. I'm kidding. 8 to the third power is 512. 9 to the third power is 729. But if we write all these down now, it's going to make answering some of the questions that you're going to see a lot easier. 10 to the third power is 1,000. 11 to the third is going to be 1,331. 12 to the third is 12 times 12 times 12. 1728. 13 to the third, 2197. 14 to the third is 2744. And 15 to the third power is 3375. I would write those down somewhere if I were you. Copy them down, write them down. That way we can reference them here in a minute. All right, so then listen out all the perfect squares between 0 and 225. Well, we just did that. It's very redundant, but this is back in your notes. And this is where we're going to write out all of the perfect squares. So the perfect square, well, I guess technically 0 could be a perfect square, right? So 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Where am I at? 3 times 3 is 9. 4 times 4 is 16. 25, 36, 49. What was that? 7. 8 times 8 is 64. 81. 100. 121, 144, 169, 196. Oh, and then there's 225. All right, so then it says step 1, find the area of a square if the side length is 10 feet. So then we're going to break it down. So it says square the side. So that would be 10 squared. What is 10 squared? Well, that's 100. And then it says undo it. Apply the inverse. Well, how do I go back to, oh no. How do I go back to, mother, oh God. How do I start at 100? How do I start at 100 and get back to 10? Well, that's me taking the square root. Square root